Hello students, we will start chapter inheritance in C++. As we all know we have heard the term inheritance. We inherit we in our own families we inherit some uh, attributes from our parents, grandparents, that is known as inheritance. When we inherit something, and we have taken multiple examples during live sessions of this chapter in the class, but I am trying to repeat the chapter on students request. This presentation is part 1. The chapter is divided into two presentations. In this I will be covering single inheritance, multi-level inheritance and multiple inheritance, and rest of the inheritances and the later topics will be covered in the part 2. What is inheritance? Capability of a class to derive properties and characteristics from another class is called inheritance. Every class has some data members, member functions which describe its properties, characteristics. When one class takes or receives those things from another class, that is known as inheritance. It is very important feature of object oriented programming, because the major benefit of this feature, of this quality of object oriented programming, is reusability. We are able to reuse the already existing properties of some class, and we are developing some new class with the help of those properties. No doubt we can add new things to the inherit new class, but we can also receive some things from the parent class. We generally we can think of like, I am receiving one house from my parent, then I am having that house, but I can purchase one more house with my earnings. So I can have two houses. It doesn't mean if my parents give me one house, now it is not allowed me to purchase some one more house from my earnings. Clear? Reusability means we are trying to reuse the existing things. Along with that, we can develop according to our needs new things. So major benefit is reusability, and indirectly, obviously, it saves time. We are not going to develop the already existing class properties. We are just inheriting those properties. Obviously, earlier class was checked, it can be used multiple times, so less errors. Every time we develop the same thing, human error can come, but already developed and tested class is available. We are just inheriting that class, so less errors. Avoid redundancy means repeatancy. Suppose we have class A and we want to give the same properties of class A to B as well as C as well as D. It means B will also develop the same properties of A, C will also develop the same properties of A, D will also develop, and that will create. In this example, we will try to understand what do you mean by inheritance. In the top of the example, you are seeing three boxes, three squares representing the class bus, class car, class truck. Class bus has three functions: fuel amount, capacity, apply brakes. Class car has also three same functions: fuel amount, capacity, and apply brakes. Class truck has also three functions: amount, capacity. It means we have created redundancy, and chances of error will also be there, as I have developed fuel amount, capacity, and apply brakes for class bus, and same functions I am developing again, wasting my time for class car and class truck also. It means there is no reusability of already existing thing in the class bus. We are developing the same thing for class car, we are developing the same thing for class truck. It means we are wasting time, we are creating chances of errors, even we are doing redundancy, repetitive work. What should be done? There should be, it means these three functions are common to all type of vehicles, bus also, car also, truck also. Should we develop one particular class by the name vehicle and put all these three functions in that class, and that class will be given to each and every car, bus, truck, whosoever wants that? See the diagram in the next part of the diagram. See, one class vehicle is there. In that class vehicle we have commonly put fuel amount, capacity and apply brakes function, and arrow symbol is going to class bus, class car and class truck, means we are doing reusability. We have developed one time, we are reusing it for car also, for truck also. We are not repeating it, we are not doing redundancy. Chances of error will also come, because one time we have checked class vehicle, if the functions are accurate, then they are just going to inherited by bus, car and truck, and less chances of error, because we are not going to develop each and every time. Human mistake or some logical mistake can be there if we repeat the task. I think inheritance is clear. Now come to the first bulleted point. Capability of a class to derive properties and characteristics from another class is called inheritance. We have just discussed this definition. Now, the class which inherits those properties, the child class, is known as subclass or derived class. The class that inherits the properties from another class is called subclass, and the class whose properties are inherited by subclass means the class which is the parent class, which is the base class, or which is the superclass. All these terms are synonyms, means they are used alternatively in the complete chapter or in any question of examination. Superclass, base class, parent class, all can be used, and subclass, derived class, child class. Clear? And how to implement, how to use this inheritance concept? In the blue box you can see the syntax. First I will write, first you have to write class, then subclass name means child class, then colon sign, access mode means the mode in which you want to inherit that base class, then the base class name, then the body of the class. Suppose we have class A, parent class, and class B, class B is the child class. Class A colon any mode, then B class, and then the body of the subclass. Here access modes can be public, private or protected. There are three types of access modes: public, private and protected. By default it's private. Now three modes of inheritance. If we derive a subclass from a public base class, then the public members of the base class will become the public in the derived class. Means we can do three types of inheritance: public, protected and private. If we derive a subclass from the public base class, means we are taking the base class in public mode, then private members can't come. It is sure that we can't inherit private members of any class. Only public members or protected members can be inherited. Public members will come in the public section of the derived class, and protected members will come in the protected section of the derived class, because we have used the inheritance mode of public. But when we inherit the subclass in when subclass inherits the base class in protected mode, then both the public and protected will get into protected section of the derived class. But if we derive the subclass from the private base class, then both the public and protected will enter into the private section of the derived class. Private members of the base class cannot be directly accessed, means in any case, in any type of mode, whichever we use, either public, either protected or private, we cannot inherit the private section of the base class. Either we should keep it public if you want to inherit, or we should keep it protected. Protected is similar to private, but the benefit is that in protected inheritance can be done, but in private inheritance cannot be done. Let's see with this example and this tabular form of various modes, and this type of table is also given in your book. And when the question of modes come, you need to discuss the public, private and protected, and even you need to give some example like the given on the screen in this slide. Along with that, the tabular form of how, when, what will happen when you inherit in public, protected and private mode. Let's discuss this table first. We have various base class member access specifiers: public, protected and private. When we inherit in public mode, public will go to public, protected will go to protected, and private is not able to get in anywhere because it will not get inherited. See the first column: when public goes to public, then public enters into public section only, protected enters into protected section only, but private doesn't enter. But when public section is inherited in protected mode, it enters the protected mode, and protected also enters the protected mode. No chance for private. But in the last column, when public is inherited through type of inheritance is private, then public will enter into private, protected will enter into private, but no chance for private to get accessed. So in any case, you can see the last row of this table: private section, whether you inherit publicly, whether you inherit protected or private, no chance to access the private data. Only chance to access is the public and protected data, and those two according to the public, protected and private inheritance modes. Let's see the example. We have class A on the left hand side, and there are three sections: public, protected and private. X is public, Y is protected, Z is private. Now class B, this is the syntax for inheritance. Class B colon, it wants to inherit A but in public mode. Now when it inherits the class A in public mode, what will happen? Just try to understand from the table what will happen from the when we will be taking A as public. Public will come into public, protected will come into protected, but private will not come. It means X is public now in B, Y is protected now, but Z is not able to get into B. Clear? Now class C. Now we are developing class C, but we are inheriting class A in protected mode. When we inherit the class A in protected mode, public will enter, a public part will enter into protected mode, means X will come into protected, Y will come into protected, but we can't access Z from here. Now last class D, it is taking A as private. So X is private, Y is private. Now we are not able to access Z. Everything is working according to this table. So you should be clear that we are developing, if we are using three modes: private, public, protected. If private section will never get inherited, public section will get inherited. If we want to keep the security from the outside access, but we want to keep the inheritance along with it, then we will should keep the data in protected mode. If we want to keep it in a highly hidden way, means it should not be accessed from outside the class, also it shouldn't get inherited, then we should keep those things in the private mode. There are various types of inheritances. First inheritance is the simple most inheritance, single inheritance, in which one subclass is developed using the one base class. means a class is allowed to inherit from only one class. As you can see from the diagram, class A is the parent class, base class, superclass, any term can be used, and class B is the subclass, derived class or child class. So what should be the simple syntax? Class B colon mode, then base class, then the body of the class. Let's see this example of single inheritance. Line number 4 in the left part of the screen, class B is developed. Class B has int A. Int A is private member because nothing is defined. By default it is private. Then public section. Public section has one data member B and three functions: get AB, get A and show A. Clear? Now that get AB, get A and show A is not defined in line number 9, 10, 11. They are defined outside the class using scope resolution operator. So you can see line number 20 is defining get AB, line number 25 is defining get A, and line number 29 is defining show A. Clear? Now come to line number 13. One more class is there, class D. We want to develop class D. It has its own members, but we want to inherit something. We want to inherit from class B in a public mode. When we inherit the class B in public mode, what will happen? Private will not come. Only public section is there in class B now. Public section will enter into public section of class D. Means in class D already you can see there are two functions, MUL and display, but along with MUL and display you will get 4 items more: get AB, get A, show A and B. Now MUL is not defined in line number 17, it is defined in line number 33, and display function is not defined in line number 18, it is defined in line number 37. So all the functions are defined. Now we will start executing these classes through main function from line number 43. 45 means D. It means first D belongs to the class, second D belongs to the object. We have created a small d object of class D. Now we know we can access the public members through dot operator. D dot get AB. Obviously D dot get AB was originally belonging to class B, but now D can also call it using dot operator like its member function, and it is member function of public section. That's why we can call from main, because it is inherited through public mode. We can call mul, we can call show A, we can call display, we can access the B data member because B is the public member of the class B and goes into public section of the class D also. I think this is clear. Now next inheritance is multi-level inheritance. It means two single inheritances joined, means there is a hierarchy. There are two parent classes, one is grandfather level, then father level, then son level. So here class C is the base class 2, class B and class A. Class A is the derived class. It is getting properties from class B, base class 1. But class B also getting properties from class C, base class 2. It means we need to define three classes in our program: class C, class B and class A. Let's see this example of multiple inheritance. In line number 4 in the left part of the screen, we are creating class student. Class student has two sections, one is protected section, one is public section. It means class student has no private section. Each and every member will get inherited. Protected section has roll number, data member, and public section has two functions, get number and put number. Though they are not defined in line number 9 and 10, we will be defining outside the class using scope resolution operator. In line number 12, get number is defined. In line number 16, put number is defined. Means part or completely class student ends at line number 19. Now another class test is defined. Class test has its own members protected members and public members, two protected members and two public members, but it is inheriting class student in public mode, means student class is inherited in public mode in class test. So all the members of class student will come in class test, because there is no private member. Protected will enter into protected section, public will enter into public section. So you can see line number 23, protected members are sub 1 and sub 2. Now it will get along with that sub 1 sub 2 roll number from line number 7 in this section. In line number 26 and 27, we have get marks and put marks function in public section, but due to inheritance along with get marks and put marks, it will get from line number 9 and 10 get number and put number. And line number 29 get marks is defined, line number 34 put marks is defined. So we have done one step of inheritance. We have class student and we have class test, and test has taken inherited class student. Now we are creating one more class result, which is taking test as which is inheriting test class result. Now that class result has its own members total and display, and display is defined outside in line number 45, but is inheriting class test and indirectly inheriting class student. So now come to the main section. We are creating the object of result class, the last class student 1. Now student 1 dot get number function is not result class function. It has received, see, it has received from student class. From student class it enters into test class. From test class it is getting enter into result class, and that's why in line number 55 we are able to use student 1 dot get number, and we are able to use student 1 got get marks function. It has received from class test, and student 1 dot display is its own function, line number 43. So there are three classes. At top level we have student, and middle level we have class test, and in the last level we have result. Now what is multiple inheritance? Multiple means we are receiving the properties from multiple hands. We are class A in the diagram shown is receiving the properties from class B also and from class C also. That is known as multiple inheritance, means one subclass and more than one base class is known as multiple inheritance. Means when we define class A colon, in suppose we want to inherit the class B in public mode, public B, and I want to inherit class C in private mode, comma private C, means I want to give the modes also of those classes as well as the classes through comma operator, and then define the body of the subclass. Let's try to understand this example of multiple inheritance. In line number 4 we are defining class M. Class M has protected member M, small m, and public function get M. Class N has protected member N and public member get N. Now we are defining line number 18 is important. The rest of the part you can understand it easily. Line number 18 is showing you the multiple inheritance. We are defining class P colon. Class P has its own member display function, but it wants to inherit the properties of M as well as N. So colon public M comma public N, means M is inherited in public mode and N is also inherited in public mode. We can, it is not compulsory to inherit all the classes in the same mode. We can do according to our own choice. Then all the functions are defined and used using dot operator. The new thing to learn is through line number 18, that in line number 18 we are inheriting the multiple classes, not one class. We are inheriting M as well as N. So what type of ambiguities arises when we use multiple inheritance? There are two scenarios. Left part of the screen will discuss scenario 1 and right part of the screen will discuss scenario 2 and their solutions. You can read the entire topic from your book in detail. Now, line number 1 is class M. Class M has function display functions. You can see in line number 4, display function is there. In N class, in line number 9, display function is there. Its own display function means display function. M class has also one display function. N class has also one display function. Now, in line number 17, when we created class P, and we have inherited class M also, class N also. Now, in in class P, if we want to execute some display function of M or N, the compiler will get puzzled because it has inherited its display function from M also and N also. So in the display function of class P, in line number 20, we will write the class name, scope resolution operator and display function in line number 22. Line number 22 in the left part of the screen is resolving the issue of ambiguity. Ambiguity means possibility of doubt, possibility of error. In line number 22, we are directly defining the display function that we want to execute. Which display function, M display function or N display function. If I execute only display function without using any scope resolution operator, then it can get puzzled because it has two options, either M or N, because it has inherited two classes, M class and N class, and both have their own display function. So we are clearly saying that we want to execute M wala display function in line number 22. Clear? Now, scenario 2. Let's discuss scenario 2. In scenario 2, you have class A. It has its display function. Class B, it has its display function. Now, what is happening? In B, we are creating one object of class B in 19 number line. Now, if I execute B dot display, it invokes the display function of class B, and if I one error is there in this slide, that in class B there should be inheritance of class A. This is the scenario of single inheritance. You can add one point in your mind that class B is inheriting class A in public mode. So class B will receive will have two display function. One its own display function defined in line number 12, and one display function which it receives from class A. So when we created its object in line number 19, and we in line number 20 we called display function, which display function it will call? Its own display function or its parent's class display function? It will call its own display function. Focus will be given to self. But if I want to execute parent class display function particularly, then what should I do? I should write the complete nomenclature of that display function using scope resolution operator in line number 21. B dot capital A class scope resolution operator display function. Clear? Now if I want to write in the similar style for class B, then B scope resolution operator display function. I think this is clear now. One error is there in scenario 2, that in class B line number 9 you have to put the colon public A, means you are inheriting class A. Now display function is of B class also as well as A class also. Examples are from your book. Few theory examples are from this link also. You can visit the link as well as the book, but material is sufficient in your presentation to understand the inheritance concept. So in the short I want to tell, inheritance means we are reusing one properties of one class, we are saving time, we are avoiding redundancy, and there are three types of modes: public, private and protected. In any case we can cannot inherit private thing, but if we want to keep data secure but we want to allow it for inheritance, then we should keep those types of data in protected mode, otherwise public mode. And then we have discussed three types of inheritance: single, multi-level and multiple. Thank you.